Math. Let's do it. It's section 3.8. It's isolating variables in equations. This is the culminating section of chapter 3. This is where you'll really test your equation solving skills. The essential question for today is, how do I get the variable by itself when there are other variables in the equation? So check this out. Oh shoot, look at that. We want to solve each of the equations for x, but this equation, there are no numbers in it at all. It's like college math. Did you know that when you get to college and do math, it becomes just a ton of like letters and theorems, and it's crazy? Your guys are going to have a little bit about that right now. So here's what we can do. When we have letters instead of numbers in the equation, we can still think of them like numbers. They're going to behave the same way as the numbers behave, because this b represents a number. I know it's a letter right now, but it's a variable, and I could plug something in for it. So take a look at what I've done. Over here, we have an equation that looks very similar to this equation, except instead of a 2, we have an a. Instead of a 5, we have a b. Instead of a c, we have an 11. But if we know what to do with this equation, we should be able to follow the same steps and figure out what to do with this equation. And I'll show you what I mean. So first of all, looking at this equation, the first thing I would do is obvious. I'm going to cancel the plus 5 by subtracting 5. That would give me 2x equals 6. So over here, instead of a 5, I have a b. Aren't I going to cancel that b by subtracting it from both sides? Now here's the issue. Here, I know 11 minus 5 is 6, because they're like terms. But b and c, they are not like terms. So how do I subtract them? I don't. On the right hand of the equal sign, I'm just going to have to write c minus b. That's the best I can do because they're not like terms, but that's fine. What am I left with on this side? Well, the b canceled. I'm left with a x. All right, great. Let's look over at this equation again. Now I need to cancel the 2, and we know since the 2 is multiplying the x, I'm going to do the opposite and divide by 2. That will cancel and leave me with x equals 3. So there would be my final answer. Here, same thing. Instead of a 2, I have an a. Let's divide by it. That will cancel here and leave me with x. Now you can represent the other side in two ways. First of all, this is acceptable. Just divide the entire side by a, so c minus b over a. That's an appropriate final answer. The other appropriate final answer is this. I don't know if you remember when we had two terms on top of a fraction and one term on the bottom, and we could distribute that division. I could distribute it here as well. So here, c over a. Here, minus b over a. I can distribute the division. So this would also be an acceptable way of writing the equation. I would accept either one on a test or a quiz, without distribution or with distribution. So not too bad, right? We just have to remember what we're doing with normal numbers. Let's do another example. Let's isolate the h. How do I do this? Notice the equations look very similar. 16 instead of p, there's a 3 instead of an L. If I know what to do with this equation, I'm going to know what to do with this equation. So let's start by this. I have 2 times 3 right here, and that's 6, right? So yeah, I could write 6 instead of 2 times 3. But the point is, now to cancel that 6, I need to subtract it from both sides. So 10 equals 2h. Over here, this is the term in question, and in order to cancel that, I can't do 2 times L. That doesn't make sense to. It's just 2L. But I know that to cancel it, just like here with the 6, I need to cancel by subtracting 2L. Again, as with the last problem, are P and L like terms? No, they're not. And so I just need to be content with writing P minus 2L. What's left on the right after the cancellation? 2H. Okay, finally, over in this equation again, I know that to cancel the 2, I need to divide through by 2, so h equals 5. Final answer there. Here, I can divide by 2. This is an easy one, and that will cancel the 2. So here again, there are two possible answers. here's the answer where I just divided the whole side by 2, or here's the answer where I distributed that division through. I'd have p over 2, thinking about the distribution. And then for the minus 2l over 2, aren't the 2's going to cancel? So I would just have minus l. So these are two different solutions, one where I did not distribute, one where I did distribute. Not too bad, right? By the way, this was the formula for the perimeter of a rectangle. That might help you on a problem on the problem set. Maybe. Okay, one last example. This is a short video. The following equation is the formula for converting Fahrenheit to Celsius. Solve for Fahrenheit to turn it into a formula that converts Celsius to Fahrenheit. So here's my issue. I have no idea about Celsius temperatures. Morocco uses Celsius temperatures, as does most of the rest of the world. But where I come from in the US, we use Fahrenheit. And so every time I hear a temperature outside, I have to do the conversion in my head because I'm not used to what does 30 degrees Celsius mean? I don't know. Is it hot or cold? I always convert it into Fahrenheit in my mind so that I can figure out how hot or cold it actually is based on my experience. So basically what I've done is I've figured out, here's the formula, but this is if you're starting with a Fahrenheit. Like you could plug in the F and do the math and get out the C. I want to figure it out in the way that's going to help me, which is plugging in the C and getting out the F. So I want to solve this equation for F, and then maybe that'll help me to see what 30 degrees Celsius is. Now, take a look at what's going on in this problem. I need to get the F by itself. What are some things that's messing with the F? Well, this is one of those problems where I have parentheses with something that I could distribute, or I could cancel it right away by multiplying by the reciprocal. So let's do that. I'm going to multiply by 9 over 5. That cancels, and on the right-hand side, I'm left with just f minus 32. On the left-hand side, I have to do the same thing, 9 over 5. Think of this like c over 1, and don't freak out. Isn't the fraction multiplication just going to be top times top, 9c, over bottom times bottom, 5? That's it. Then, finally, to solve for f, all I have to do is add 32 to both sides. Whoops, I added 22 there. Should be adding. Silly Mr. Gregory. All right, so here's 9 over 5c. Is that a like term with 32? It's not, and so I need to leave them separate. So my final answer is going to be 9c over 5 plus 32. I couldn't actually add them together because they are not like terms. On the right, the minus 32 has canceled, and I'm left with just f. So this is my final equation. And look at how this can help me. Let's say I don't know how hot 30 degrees is. So I could plug 30 in for C. I know that I'm going to multiply by 9 and divide by 5. So 30, I'll do the division first. 30 degrees Celsius. Okay, I'm dividing by 5, that's 6. But then I need to multiply by 9, that's 54. And then I need to add the 32, so that's 68. Whoops. 68 degrees Fahrenheit. And now I have a really good reference. I can say to myself yeah, that's maybe sweatshirt weather, but probably still shorts and a t-shirt weather. So it's very helpful sometimes to solve for other variables. All right, here's your summary. When isolating the variable, it really helps to imagine the other variables are just regular numbers. That's why I showed you a comparable equation in example 1 and 2 with regular numbers. The variables are going to behave in exactly the same way as these other numbers do, so it can really help. Thanks for watching, guys. Hope you enjoyed this section. It's kind of a fun one, a little bit tricky, but once you get it, it should be straightforward. By the way, did anybody notice the mistake I made on this slide? It shouldn't be 68 degrees Fahrenheit. It should be 86 degrees Fahrenheit. That's definitely shorts and a t-shirt weather. All right, there was your bonus ending. See ya, bye.